In this video, we're going to take a look at the basic idea of a union type. So a union type is kind of related to a struct. Now, in a struct, we have a single data type. It's a composite data type that contains many different little parts. So I can have, two integers, for example, inside the same struct, and they could essentially live side by side. So I have A and B, both could be ints right there in the same thing. A union somehow looks the same as a struct. You can see the declaration here is in the middle. It looks kind of like a declaration for struct, right? The only difference is the fact that we're using a different keyword. Everything else looks the same. And I could have in here, right, my int x, int y. I could have them side by side in there. Unlike a struct, what an union is actually going to do is it's not going to have space for x and y at the same time. The idea of a union is that you have a bunch of members of the specific type, and only one of them at the time can actually be used. So a union contains only one value, right? A struct contains many values, right? It's a composite type. A union only contains one thing. And so in this union type, I could have maybe a dozen variables. I don't necessarily have space for each of them individually. I'm only limited to using one at a time. So this is a little bit of an issue you can maybe imagine, because in a union type, you have to know what is the active variable inside of it. So here, right, I have my type 1, type 2, type n, right? In the union, I can't use them arbitrarily, right? I have to know, oh, hey, I'm using that union variable to store whatever is of type 2. Type 1, I can't use that. That's not what it's being used as. So a union is basically, maybe you can think of it even as being a generic, right? I can have different things inside of there, right? Could be a list of different types, and this variable that's of a union type can be one of these. It can't be all of them at the same time. It can be just one of them. This can get a little confusing, right? We have to keep track of what it is that I'm storing inside of a union variable, and also it uses the same syntax as a struct, so that dot operator is what you'll use, and so sometimes people get confused, oh, am I using a struct or am I using a union? So why is a union useful? This is kind of the big question here. So maybe you think to yourself for a second. Well, the reason a union is useful is because sometimes we don't know ahead of time what we want to store in a variable. So actually, the example of generics, right? This could almost be one way, for example, to have a linked list that can store different types. So I could have a linked list node that linked list node has inside of a union, so it can store, a character, an int, a float, a double, whatever. Right, these can all be writing side by side in the same union type. And so what that would do is basically have this new variable type, right, this union, and it can be any of those four things. And so if I build my linked list from those union types, well, I would basically have my choice. Do I store this, or do I store that, or do I store that? So I get some flexibility there. So anytime I am presented with this case where I have a variable, and I don't know exactly what type it's going to be, I know it can be one of these, but I don't know exactly which one, then maybe I can use a union. So based on our description of a struct, we also want to ask the following question. How might memory be allocated for a union? The basic idea is this. The size of a struct, instead of being the sum of the size of each of the elements inside of it, is simply the size of the largest thing inside of it. So the struct can store all these different variable types. What is the largest thing in there, right? That union, the size of that union, needs to be equal to whatever is the largest thing in it, because it needs to have enough space in order to store that thing. So internally, right, the compiler will look for it. It'll try to figure out how many bytes does the largest thing need in this union, because that could contain that, and that'll be the size of this union. Now, if the union is storing something that's smaller than that, it'll only use part of the information. So you can imagine, maybe you have a union and it has an int in there, which is going to be 4 bytes, and a string of 256 characters. So the union maybe looks like this, right? And over here we have maybe our int, right? As using that first part just was first 4 int. My int, and then on the right hand side, you potentially have a string, right? 256 bytes. So I have all the rest of those 252 remaining bytes would be over there. Now my union type basically is going to be the size of that entire thing, right? So there's 256 bytes for the entire string. That's how big the entire union would be. And if that union is being used as a string, then it'll use all that 256. If it's only being used as an int, it'll just use those first 4 there. So these you can almost picture as being kind of although they're on top of each other, right? Rather than being 4 bytes followed by 256 like it would be in a string, they're layered on top. So the first 4 bytes are for int, and then the next 252 bytes, right? Basically 256 minus 4, and the rest of those 252 bytes, those basically are going to follow that int, and those are going to be what is used if you choose to store a string inside of this. So you can just picture, right, if all these different variables are just being stacked on top of one another, right, with the largest one at the very bottom, because you need to have space to at least store that thing. All right, so that's how memory allocation will go for a union. Let's take a quick look at some code that uses it. So over here we have an example, boilerplate stuff at the top, then we're defining a union type. So our union type is int, is ID, and it contains 2 things, a student int and faculty char. So this is actually kind of like the picture I drew a minute ago. And then create a new union ID variable called personnel. And look over here at main. So basically what we're saying is, okay, I have this variable called personnel. And this variable called personnel, right, is of the union type. How can we manipulate it? So the first thing we're doing there is we're going to personnel.faculty and we're copying in the string. So we're basically storing into that faculty variable, or that faculty member. Okay, so that's fine. That code looks like we're using a struct even. And then we go down to the next line, personnel.student equal and then ID number. Okay, again, it looks like we're using a struct. The important thing to realize is this. In the memory for our union, which is 256 bytes, originally we had used the front part of that basically to store that string. Well, now when we do that dot student equal the number, we're basically going to go and say, okay, that first 4 bytes out of that union, it's not going to represent that string anymore, right? It doesn't have anything to do with the letter A or the number 1 or anything else. Those first 4 bytes, because we're doing that dot student and assigning into it, those first 4 bytes now store this particular number, this particular ID number. And so we're going to lose part of that string information. Okay, because the point is, right, is that my union doesn't contain separate pieces of data. They're all layered together, right? They're all in the same storage space because I just get my choice of, I can use any of these, although I can't use them at the same time. I just have to pick the one. Now, if I were to go to this code and go to personnel.student and try to display it out, I'll get back the number, right? That's fine. I just did the assignment in there. That'll be what I expect. But then what I get is I get weird stuff when I do something like personnel.faculty. I don't get that string, right? That I stored in there because that first part of the string, right, the first 4 bytes have been overridden by the bytes that are needed to store that student ID number. So that A112, all of that you can see has been replaced. There's some gibberish in my window down below, right? I can see that I have over here this stuff. That's basically what happens when we say, okay, those first 4 bytes of that union, we put that number in there, but then we're saying, I want to print out the faculty. Well, that faculty, right, has some good string data in there, but those first 4 bytes were overridden by that student ID number. And so whatever characters that student ID number happens to map into, that's what's showing up there on my screen. Okay, so I'm only allowed to use one thing at a time. Here, because it's the student is the last thing I store into it, that's what's going to be the valid data inside. As a last note there, you can see we do a size of operation. And the size of operation, right, is showing that it's 256 bytes long. So it's not 260 to store 2 things. It's 256 because it's just going to store the biggest thing, right? That's that string. And then based on what we want to have, right, that string versus the int, we'll just reuse the same bytes. So there you have it, an idea of how to use union.